Hello guys, welcome to SS Corner. Previously we discussed about Lagrangian and Hamiltonian and we saw that Lagrangian is a function of generalized position velocity time and Hamiltonian is a function of generalized position momentum time and they are connected by legendre transformation. Now suppose you are given a Lagrangian and you want to convert it to a Hamiltonian, then what are the steps that we have to follow? At first, we see that Lagrangian is a function of generalized position velocity time and Hamiltonian is a function of generalized position momentum time. So both the Lagrangian and Hamiltonian contains the common thing, position as well as the time. So if you want to change a Lagrangian to a Hamiltonian, you have to make a relation between the velocity and momentum. That means you have to replace the velocity value by the momentum value if you want to change a Lagrangian to a Hamiltonian. So there are several steps involving if you want to change a Lagrangian to a Hamiltonian. I am going to writing some steps. Please follow me. Step number 1. Find the generalized coordinate. I am writing in shortcut GC and generalized velocity. I am writing the shortcut GV. Step number 2, find the momentum, obviously generalized momentum, by the relation Pj equals to del L del Qj dot. Step number 3, make a relation between velocity and momentum. Step number 4, put the velocity value, that means velocity in terms of momentum value, in Legendre transformation. So these are the steps if you want to change a Lagrangian to a Hamiltonian. By following the steps, I'm going to change a Lagrangian to a Hamiltonian. So you can see a question, a very simple question, a very simple Lagrangian of a simple pendulum, that is L equal to half ml square theta dot square minus mgl into 1 minus cos theta. And we have to change it to a Hamiltonian. So at first, by following the steps, step 1, find the GC and GV. So in this Lagrange, the generalized coordinate is theta and the generalized velocity is theta dot. Step 2, find the momentum by the relation Pj equal to del L del Qj dot. Here the momentum, generalized momentum will be P theta, that is equal to del L del theta dot. So if you differentiate partially with respect to theta dot of the Lagrangian, you would find the P theta value would be ml square theta dot. Step 3, relation between velocity and momentum, that is theta dot equal to P theta by ml square. Step 4, put the velocity value in terms of momentum value in Legendre transformation, that is H equal to, the Legendre transformation is H equal to P theta into theta dot minus L. That means the multiplication of momentum and velocity minus Lagrangian. So P theta into theta dot means P theta by ml square minus L, that is half ml square theta dot square, that means P theta square by ml n square L to the power 4 minus mgl into 1 minus cos theta. So the Hamiltonian would comes out to be P theta square by 2 ml square plus mgl into 1 minus cos theta. So in this way, you can find the Hamiltonian if you are given a Lagrangian. You have to follow the steps. That means if you, at first you have to find the generalized coordinate and velocity, then the generalized momentum, then velocity and the momentum relation, and put that velocity in terms of momentum value in the Legendre transformation. You can easily find out the Hamiltonian. Okay, so in this way, this is the Hamiltonian of a simple pendulum. You are given a Lagrangian of a simple pendulum and I have converted it to a Hamiltonian of a simple pendulum. Okay, so in this way you can find out the Hamiltonian. This is very much easy and simple steps. So try to solve more and more problems regarding Lagrangian and Hamiltonian, and that's it for today.